Hello everyone. Today is the fourth lecture on matrix. We are on basic concept of matrix. Okay. So today we start transpose of a matrix. Let a matrix say equal to Aij of order m by n. That means it have m rows and n column. Then a matrix which is obtained by interchanging the rows and columns of A is called the transpose of A, and that is denoted by A dash or A transpose. That is, if A equal to Aij of order m by n, then A transpose would be of order n by m. It means here we interchange rows by columns. So is that clear? For example, if A equal to 235,167 of order 2 by 3, then its transpose is, we can write it as this. Now we make rows by column. So this will be 235 and the second row is 167. So this will be column 167. So here the transpose matrix is of order 3 by n. So is that clear how we can make it, how we can find the transpose of a matrix? Okay. Now we go for properties of transpose of matrix. If A dash and B dash are the transposes of the matrix A and B respectively, then A transpose is equal to A. It means transpose of A transpose of A is again A. That means if we have a matrix, then first we find the transpose of that matrix. It means now the number of rows will be number of column, and then again find the transpose, then number of rows will be the same as the original matrix. It means the transpose of A is A. Okay, so this is the first property. Now we go for second. uh, A plus B transpose equal to A transpose plus B transpose. So here A and B must be of same order. And the third is the multiplication by scalar. So K of A transpose equal to K bar A transpose. Here K then is scalar. Now we go for fourth. A plus B transpose equal to B transpose A transpose. Here AB and B transpose A transpose are conformable for matrix. So is that clear? Now we go for next, symmetric matrix. A matrix A is said to be symmetric if its transpose is equal to matrix itself. Okay, that is A transpose is equal to A. Then we say that this matrix is symmetric. For example, if we have a matrix equal to 1, 2, 3, 2, 4, 5, 3, 5, 6, then A transpose will be, now we interchange first row with first column. So we write this 1, 2, 3. This is second row with second column. So 2, 4, 5. Third row with third column. It means again this is that original matrix. It means A transpose equal to A. Hence A is symmetric matrix. So is that clear how we can find symmetric matrix? Skew symmetric matrix. A matrix A is said to be skew symmetric a matrix if its transpose is equal to matrix itself with negative sign. Okay, this is skew. So let us take one example. We have equal to 0 to 3 minus 2 0 4 minus 3 minus 4 0. Then a transpose will be, now we convert first row with first column, 0 to 3, second row with second column, minus 2 0 4, third row with third column, minus 3 minus 4 0. If we take minus in outside, then we get 0 to 3 minus 2 0 4 and minus 3 minus 4 0, which is the original matrix. It means here A is equal to minus A transpose. Okay, so then we say that this is skew symmetric. So is that clear? Property of symmetric and skew symmetric matrix. If A is a symmetric matrix or skew symmetric matrix, then Ka means when we multiply by scalar, then it's again a skew matrix or symmetric matrix. Okay. If A and B are symmetric or skew symmetric matrices, then the sum of A plus B is also symmetric or skew symmetric matrix. Third is if A is any matrix, then A transpose and A transpose A both are symmetric matrices. Okay. If A is any square matrix, then A plus A transpose is symmetric and A minus A transpose is skew symmetric. So these are the properties, and the last one is all positive integral power of a symmetric matrix are symmetric. That is A raised to the power m is symmetric matrix if A is symmetric. So is that clear? So now we go for next complex matrix. A matrix A is said to be complex matrix if it contains some of its element equal to a complex number. It means it may contain a complex entry also. Okay. Now we go for conjugate of complex matrix. Let A be a complex matrix, then a matrix which is obtained by replacing all the complex element of A by other complex conjugate number is called conjugate of matrix. It is denoted by A bar. For example, if A equal to 1 plus 2i, 3i, 6, 7, 2 plus 4i, 1 minus 1 plus I, then the conjugate will be, you have to replace, for find the conjugate matrix, you have to replace I with minus I. So here this will come 1 minus 2i minus 3i, 6, 7, 2 minus 4i and 1 minus I. So this is the complex conjugate of A. So is that clear? Now we go for next. Transpose conjugate of a matrix. The transpose of the conjugate matrix is called transpose conjugate of that matrix. It is denoted by this. Okay. Therefore, the transpose conjugate of A, we can write it as A conjugate and this. So this is this. It means this is the conjugate of A, then we find the transpose. Okay, to find the transpose conjugate. Properties of transpose conjugate to a matrix. A transpose conjugate is equal to A. If A plus B transpose conjugate equal to A transpose conjugate of A plus transpose conjugate of B, where AB being of same order. K of A, the transpose conjugate equal to K bar transpose conjugate of A, where K being a complex number. Okay. And fourth one is AB transpose conjugate of AB equal to transpose conjugate of B into transpose conjugate of A, or AB being conformable for multiplication. So is that clear? Now we go for Hermitian and skew Hermitian matrix. So first one is Hermitian matrix. A matrix is said to be Hermitian if transpose conjugate of A is equal to A. Okay, and a matrix skew Hermitian matrix. A matrix is said to be skew Hermitian if transpose conjugate of A is equal to minus A. Okay, now we go for orthogonal and unitary matrices. ऑर्थोगोनल मैट्रिक्स क्या होती है? A matrix A is said to be orthogonal if A and A transpose. This is transpose is equal to A. It means product of matrix and और उसका ट्रांसपोज का जो मल्टीप्लिकेशन है वो यदि आइडेंटिटी मैट्रिक्स है then we say that that matrix is orthogonal matrix where I is a unit matrix of order same order as the order of A. Okay, for example, if A equal to this cos theta sin theta minus sin theta cos theta, so first we find the transpose of A. This will be cos theta sin theta minus sin theta cos theta. Now we product these two matrices cos theta sin theta minus sin theta cos theta minus sin theta cos theta. Okay, when we multiply this by this, so this is cos square theta plus this multiply by this sin square theta. Okay, in a similar manner, we get cos theta minus sin theta plus sin theta cos theta. This will be 0 minus sin theta cos theta plus cos theta sin theta. This will again 0 minus sin square theta. This is minus into minus plus, so this will come minus. This will come sin square theta plus cos square theta. So A does this will we know that this is 1, so 1 0 0. It means this is unit matrix. So A is orthogonal matrix. So is that clear? Okay. Now we go for unitary matrix. A square matrix A is said to be unitary matrix if transpose conjugate of A multiply by A equal to I. For example, if we have A equal to 0 minus I 0, then first we find conjugate of A. So this will be, we replace I with minus I, so this will come plus I and this will come minus I, 0. Then we find the transpose conjugate. It means now we transpose this matrix, so this will be 0 I minus I 0. Okay, now we multiply A with A transpose. Okay, now we multiply A transpose with A. Okay, so this is A transpose 0 I minus I 0 0 minus I 0. After multiplying, we get 0 minus I square 0 0 minus I square plus 1, and we know that the value of I square is minus 1, so this will be 1 0 0 1. It means unit matrix. So hence A is unit matrix. So is that clear? Now we go for properties of Hermitian and skew Hermitian matrix. If A is Hermitian, then IA is Hermitian matrix. Okay. If A, B are Hermitian or skew Hermitian, then A plus B is Hermitian or skew Hermitian. If A is Hermitian or skew Hermitian, then A conjugate is Hermitian or skew Hermitian. So these are the properties of Hermitian and skew Hermitian matrix. Okay, now we go for on exercise. Some question of this exercise we have done in previous videos and the remaining questions we solve today. Okay, so we are on question number 6. It is given that A is 1, 2, 3, 4, B is 2 minus 4 minus 3, 1, C is 1, 2, 3 minus 1, and we have to find A plus B of C equal to AC plus BC. We have A equal to 1, 2, 3, 4, B equal to 2 minus 4, 3, 1, C equal to 1, 2, 3 minus 4. So first we add A and B. It means we find A plus B. So this will be, this is A matrix, this is B matrix. We can simply add, it means we add corresponding. 1 plus 2 is 3, 2 minus 4 is minus 2, 3 minus 3 is 0, 4 plus 1 is 5. And now we multiply C with A plus B. Okay, here A plus B is this and C is this. So after multiplying, we get minus 3, 8, 15, minus 5. Okay, now we multiply A with C. Here matrix A is this 1, 2, 3, 4 and matrix A is 1, 2, 3, minus 1. Then we after multiply we get 7, 0, 15, 2. Similarly, we find BC. This is B matrix and this is C matrix. We get minus 10, 8, 0, minus 7. Okay. Now we add AC and BC. This is AC and this is BC. After adding, we get this matrix 3, 8, 15, minus 5. So from equation 1 and 2, we get A plus B into C equal to AC plus BC. Hence, is that clear? Okay. Now we go for question number 7. If 401523 and this is equal to this, find the value of x, y, z. So first check that these are the conformable. Here the order of this is 2 by 3 and the order of this matrix is 3 by 3. It means the number of columns in first row is first matrix is equal to number of rows in second. It means the multiplication is conformable. So we can multiply these two matrices. So the order of this matrix will be 2 by 3. Okay. So after multiplying, we get this matrix 17, 24, 32, 4, 12, 11. Okay, and this is equal to 8x plus 3y, 6z, 32, 4, 12, 26 minus 5y. And we know that two matrices are equal when corresponding elements are equal. It means first element of this matrix is equal to this one. So 8x plus 3y equal to 17. So we say this is first equation and second element of this is equal to second element of this matrix. So 6z equal to 24. This is equation second. This is third element. This is equal to this. This is fourth element. This is equal to this. And this is fifth. This is equal to this. So this is sixth. So this is equal to this. So 28. 6x minus 5y equal to 11. Okay, so after solving these equation, we get x equal to 1, y equal to 3, z equal to 4. So is that clear? Now we go for question number 10. Find the product of AB. So here in first A is 1, 2, 3, 4 and D is 1, 7, 2, 3. Okay, so the product of A and B. First we check the order. So here the order of first matrix is 2 by 2 and also order of second matrix is 2 by 2. So it means the number of columns in first matrix is equal to number of rows in second matrix. It means product is conformable. So the product is AB equal to this is first matrix, this is second. So we can easily multiply it and after multiplication we get this 5, 13, 11, 33. Okay, so AB will be this. So is that clear? Now we go for checking part which is A equal to this and B equal to this. So here the order is 2 by 3, order of B is 3 by 2. It means number of columns in A is equal to number of rows in B. So the product is conformable. Okay. And now the product of A and B will be this. After multiplying both these matrices, we get 3, 8, 8 minus 12. Okay. Now we go for third part. Here is XYZ and B is this XYZ. This is the column matrix and this is the row matrix. Okay. So first we check the order. The order of A is 3 by 1 and order of B is 1 by 3. It means the number of column in A is equal to number of rows in B. So the product is conformable. The product will be AB. So we can easily find the product of these matrices. This will come x square, xy, xz, yx, y square, yz, zx, zy, z square. So is that clear? Now we go for next question. If A equal to this 100, 010, then prove that A cube equal to A. So here we have 100, 010, equal. Now we find A square, so we can write A multiplied by A. So this is A, this is also A. We can easily multiply, then we get this. Okay. Now we find A cube, so we can write it as A square into A. Here A square is this and A is this. So we get this. Hence A cube is equal to A. So is that clear? Now we go for question number 15. Find the additive inverse of a matrix. We know that the additive inverse of a matrix is the negative of that matrix. Okay. So we find the negative of this matrix. It means we multiply all the elements of this matrix with -1. So we get the additive inverse of this matrix is -1, -2, 7, -5, 0, -5, 0, -8, 0, 0, 8. So is that clear? Now we go for question number 16. Are the following matrices are conformable for product AB? So the first is the order of this matrix is 2 by 2 and order of this matrix is this is of 2 by 2 and this is of 2 by 3. So it means the number of row, number of column in first A matrix is equal to number of rows in B matrix. It means product is conformable. Okay, now we go for second. Here the order is 2 by 2 and order of B is 2 by 1. So the number of columns in first matrix is equal to number of rows in second matrix. It means product is conformable. Okay. Now we go for third part. Here the number of the order of this matrix is 3 by 3 and order of this matrix is 3 by 4. It means the number of columns in A is equal to number of rows in B. It means the product is conformable. Okay. Now we go for fourth. Is the order of this is 1 by 4 and order of B matrix is 4 by 1. So the number of columns in A is equal to number of rows in B. It means the product is conformable. So all these questions are clear? Okay. Now we go for question number 18. Transpose a matrix. Means we have to find the transpose. I told you that how we can find it. Means we change the number of rows by number of columns. So the first row is will be the first column. So this will be 1, 3, 5. Second row will be the second column -2, 5, 6. And third row will be the third column 7, 0, 3. So this is the transpose of this matrix. So is that clear? Now we go for question number 19. If A equal to this matrix, B equal to this matrix, find 2A minus 3B and B minus A by 2. Also write down the unit matrix of order 3. So here we have A equal to this and B equal to. Now we find 2A. It means we multiply each element of A by 2. So this will come 4, 2, 8, 10 minus 6, 14. Also find 3b. It means we multiply each element of b by 3. So 3, 6, 9, 6 minus 12, 18. So 2a minus 3b will be 4 to 8, 10 minus 6, 14, minus 3, 6, 9, 6 minus 12, 18. Okay, so this will come 1 minus 4 minus 1, 4, 6, and minus 4. Okay, after subtracting. Also, we have to find b minus a by 2. So to find a by 2, we can divide each element of a by 2. So after subtracting, we get 0, 3 by 2, 1, minus 1 by 2, minus 5 by 2, and minus 5 by 2. Also, we have to write down the unit matrix of order 3. So this is the unit matrix 1, 0, 0, 0, 1, 0, 0, 0. So is that clear? Question number 20. Verify the matrix 1 by 3, 1, 2, 2, 2, 1, minus 2, minus 2, 2, 1 is orthogonal. So we have matrix A equal to this. Now we find the transpose of A. This we convert the rows in, we interchange the rows in columns. So the first row will be first column 1, 2, 2. Second row will be second column 2, 1, minus 2. Third row will be third column. Now we multiply A transpose with A. Okay, so we can write it as like that. Okay, so after multiply we get this, and now we divide it by 9 all elements, so we get 1 0 0 0 1 0 0 0 1, and which is equal to unit matrix, hence A is orthogonal matrix. So is that clear? Now we go for objective type questions. So question number 21 is 35793759. Is true or false? Is all these matrices are equal? No, this 5 is not equal to 7. This 7 is not equal to 5. So this is false. Is that clear? Now we go for question number 22. If A equal to 1001 and B equal to 3467, then A plus B is 4468. So first we edit 1 plus 3 is 4, 0 plus 4 is 4, 0 plus 6 is 6, 1 plus 7 is 8. It means it is true. Okay, now we go for question number 23. If A equal to this, then find 5A. Means we multiply each element of A with 5. So this will come 5, 10, 15, 25, 30, 35. But this is on here, this minus sign is not here, so it means this is false. Okay, now we go for 24. Square matrices are always conformable for multiplication. Yes, it is true. Okay, now we go for question number 25. Is square a matrix is symmetric if A transpose equal to minus A? No, A transpose equal to A for symmetric matrix. This is false. Now we go for question number 26. The diagonal element of a skew symmetric matrix are all 0. Yes, this is true. Now we go for multiple choice questions. The unit matrix of order 2 is, this is 1 0 0 1. In unit matrix, the diagonal entries will be 1 and all other entries will be 0. So here diagonal entry is 1. Okay, both principal diagonal entries. So is that clear? Okay. Now we go for question number 28. A matrix A is symmetric matrix if A transpose equal to minus A. So the first one is right. A matrix is Hermitian if A transpose conjugate is equal to A. A B dash equal to B dash A dash. A B conjugate transpose equal to B conjugate transpose into A conjugate transpose. Okay. If A equal to 1 minus 1 minus 1 1 B equal to this, then A plus will be. A plus B will be. Now BI corresponding entries 1 minus 1 is 0, minus 1 plus 1 is 0, minus 1 plus 1 is 0, 1 minus 1 is 0. It means first option is right. The last question is the order of the matrix this. So here the number of rows is 2 and number of columns is 4. So the order of this matrix will be 2 by 4. Okay. So is that clear? So today this chapter is completed. Okay. Thank you for watching this video.